Here we are, ladies and gentlemen. It is Wednesday, and we are like halfway, a little bit more than halfway finished with Unit 3. So I'm hoping now that I basically taught you all the difficult tasks as it relates to multiplying fractions. Now you guys can just polish them. Okay, so you're confused a little bit. Well, now every day we'll focus on being a little bit less confused. So for example, on the challenge questions, I just focused on the steps of multiplying fractions. So like, let's pretend the middle is our goal here. The first thing that we have to do is know how to turn it into an improper fraction. So I just focused on that step with the first challenge question. And then after, another thing is when we're multiplying, it's really nice to know how to reduce fractions or simplify, and that's where I focused on that over here. So let's rock and roll. Let's get into this. It says the first thing you need to do, turn into improper fractions. I don't know why there's an S. I only ended up putting one thing there. So let's do that dance here. We have 5 1/3, and we want to turn 5 1/3 into an improper fraction. Well, right now it's just a mixed number. How do we know? Because we have a whole amount and then we have not a whole, right? This is somewhere on a number line between 5 and 6. So what we'd like to do is take this entire amount, go to the fraction bank, and turn it into a whole bunch of thirds. Now, your number is going to get larger on the top because you have more than a whole. And 3/3 is equal to a whole. So each of these, so there's 1, 2, 3, 4, 5. Each whole is 3/3. You have 1 whole, 2 wholes, 3 wholes, 4 wholes, and 5 wholes. So you just in the holes, the 5 holes, you have 3, 6, 9, 12, 15. So just here, right here, you have 15 thirds. But do you only have 5 that you're turning into thirds? No, you also have 1/3. So you have not only 15, but you also have 1/3. So turning this into an entire improper fraction, turning the whole thing into thirds, it's equal to 16 thirds. Okay, so your answer is 16 thirds. And the way that I usually teach it to folks is the formula that you could use to turn a mixed number into an improper fraction is, well, a mixed number has a whole number, we'll call that a W, and it has a numerator and it has a denominator, right? So what you do is you take your denominator. First of all, your denominator is going to be in your answer, right? So keep the denominator the same in your answer. And then you multiply the denominator and the whole number. So here it was 5 times 3 is 15. So you multiply those, and then you just simply add this way. Add that answer to the numerator, the top number, and that's your answer. So on the top, it's D times W plus N. So the top, your new top is denominator times whole number plus numerator, and that answer is going to be written with the denominator staying the same. So the answer to number 1 is 15 plus 1 is 16. So that answer is 16 thirds. Okay, so let's now apply that to multiplying these fractions. So we have, hi, matey. The only way you can multiply fractions is by fitting it inside of Mr. Krabs' eyeballs, right? The only way you can multiply fractions is taking a numerator, multiplying it by a numerator, taking a denominator, multiplying it by a denominator. Nowhere in there is there room for a mixed number. So your first step when multiplying 5 1/3 by 3/8 is get rid of the mixed number by turning it into just a fraction. So the way that you turn it into an improper fraction is 5 times 3 is 15, and 15 plus 1 is 16. So this, let me put his eyes down here, is 16 thirds, going to multiply that by, is 3/8 already just a fraction? Yes. So we're going to multiply that by 3/8. Now, two options. We could just multiply across 16 times 3. Well, that's kind of an ugly number. And 3 times 8. But remember, if you multiply across, there's nothing wrong with that. So you take 16, multiply it by 3, you get 18, and you get 48. So that would be 48. And then 8 times 3 is 24. Now, how many 24s are in 48? Well, 24 plus 24 is actually 48. So that answer is 2. But remember, what you could have done instead is you could have said, oh, okay, instead of having 16 and 8, I know I can count by 8s for both of those. So therefore, the 16 would turn into a 2, and the 8 would turn into a 1, because I can count by 8s. 1 8 makes 8, 2 8s make 16. Or if you didn't know that, you could at least cut it in half, turn that into an 8, that into a 4. And then the 3s, you can count by 3s for both of them. Turn this 3 into 1, turn this 3 into 1. Now it's just a lot easier. Same answer, 2 times 1 is 2, 1 times 1 is 1, and 2 over 1, again, is 2. If you would have just said, oh, I'm going to cut those in half because they're even, the 16 would have been 8, the 8 would have been 4, and then 3 and 3, most of you guys could see, oh my gosh, they're the same number. You can just count, you can just turn them both into 1s because you can count by 3s for both of them. If you would have gone this route, you would have said 8 times 1 is 8. You would have said 1 times 4 is 4. And 8/4, you could pull out 4, 4. You could pull out 2. That way as well as 2. And remember what I've told you guys time and time again, that math, especially multiplying fractions, it's that door is the question, that door is the answer, and there's so many different paths to get from the question to the answer. Okay? Doesn't matter. Don't feel like you have to just choose one path. There's only one right path. I got to figure out what Mr. Stahl is doing. No. There's many different ways to get to the answer. So you choose the one that you are comfortable with. Okay. So that answer, after you do all that math, is 2. Now to simplifying. Okay. Like just, I probably lost some of you guys when I showed you the different ways that you could simplify. So let's go over simplifying a little bit. We have, remember, whenever I show you guys equal fractions, I start with, usually I use 1/2 and I go this way. It's the same as 2/4 or 3/6 or 4/8 or 5/10 or 6/12. And then I say, you can go this way infinitely, right? You can go that, I can't stand that light. You can go this way infinitely, forever. But the smallest equal fraction is right here. Every time you take a fraction and find its smaller equal fraction, you are what they call just reducing. But you can continue to reduce until you find the smallest equal fraction, which there is 1/2. So simplifying means taking a fraction and reducing it until you cannot reduce anymore. Remember, this is when I had the boxing. So I like jabbing. See how they're both even? Whenever they're even, you can just jab it. A lot of you guys could just look at that and say, oh man, I can count by 6s for both of them. That was never me growing up. I'd freak out trying to go through all my facts to figure out which one it is, when in all reality, I could just cut them in half real quick. Now I have to look at those and make sure, let me put it down here. Make sure 9 and 12 doesn't have any in common, but it does have something in common. 9 and 12, you can count by 3s for both of them, right? How many 3s make 9? 3. How many 3s make 12? 4. So this answer up here is equal to 3/4. And if you would have just used 6s in the beginning, because you saw that, you would have noticed that it takes 3 6s to make 18, and it takes 4 6s to make 24. That would have been just a different route to get that same answer. Okay, now 10/35. See how they both end in a 5 or a 0? What number can I count by that goes to 5 or 0? 5s, right? So you look at it like, you know, there's a lot of different ways that teachers are going to teach you, like terminology wise, the words that they use, how to do this. The way I like looking at it is like dollar bills, because it's just easy to think of. So if you're using a $5 bill for both of these, all I have to write is how many $5 bills it takes. How many $5 bills does it take for 10? 2. How many $5 bills does it take to 35? Well, let's count. 5, 10, 15, 20, 25, 30, 35, 7. So therefore, this can't go any smaller. 2/7 is your answer there. 2/7 is 10/35. Simplify. And what about 14 over 21? Well, they're not both even, so I can't just cut them in half. What else could I do? Threes? No, I can't count by threes for 14. And sometimes you won't see it. You literally won't see it. Very, like, not all the time, but once in a while you won't see it. So you're just going to say, it might be simplified. I think maybe it's simplified. This one's not simplified. If you go through all the factors of 14, it's 1, 14. These are all the dollar bills you can use to make 14. 2, 7. Those are the only things. Can I count by 14s for 21? No. Can I count by 7s for 21? Yes. So I can use 7s for both of these. How many 7s make 14? 2. How many 7s make 21? 3. So that answer is equal to 2/3. And those are your challenge questions, except for that challenge question itself. So Paul wrote some notes to 3 friends, A, B, and C. A, B, and C. He puts the notes into the addressed envelopes, but then he realized he wasn't paying attention to matching notes with envelopes. In how many ways could none of the notes be in the right envelope? How many ways can none of the notes be in the right envelopes? So, A, B, and C, A, B, and C. So one way is A could be in A, and B, if A was in A, B would be into B or C, and C would be into A would be into A, B would be into B would be into B, and C would be into C. That's one way to do it, right? The other way to do it is A would be into B, and if A was into B, then B could be into C, and C could be into A. Now this one up here doesn't count because this one's in the right one. This one is not in the right one, right? They're all in different ones. Now, is there a different way to find them all in different ones? Well, if A wasn't into B, it could be into C. And if A was into C, then B would have to be into A. And then that would put C into B. These are the only 2 ways to get A, B, and C into different envelopes. So that is confusing. Well, there's 2 ways to get them into different envelopes. There's no other way, because A, the only other thing A can go into is A, and then it would be in its right envelope. So once again, those are challenge questions. If that made sense to you, awesome. If that did not make sense to you, don't worry about it. Those are just challenge questions. It's like a puzzle. So don't worry about it. That's why I try to put it in a different color. All right. So that's there. There you go. Yes. 2 ways. Okay, let's move on. We are now going to compare these different things. So we're going to look at fractions. We're going to compare. We're going to add. We're going to subtract. We're going to multiply. So the first one, all right, so what we're doing here is we're going to look at 2/5 and 7/10. We are going to compare them. We are going to add them. We're going to subtract them, and we're going to multiply them. So the first thing that let's compare them. Let's put our 2/5 and 7/10, and then let's see which one's larger. Well, oh, what I'll do is I'll just turn 2/5 into tenths. 2/5 equals how many tenths? Well, from 5 to 10 is times 2, so 2 times 2 is 4, so it's 4/10. What's bigger? 7/10. 7/10 is larger. Okay, now let's add them. 2/5 plus 7/10. Remember, I got to add up and down. And then when I add them, I got to say Beyonce. What's their name? Tenths. So 2/5 equals 4/10. So I'll write that. So now it's just 4/10 plus 7/10. 7, 8, 9, 10, 11. Oh, 11/10 there. 11/10 is bigger than a whole. 10/10 makes a whole. So I could pull out 10, make it a whole. Is there any left over? Yeah, there's one left over. So it's 1 and 1/10. Now let's subtract them. Ooh, remember, 7/10 is bigger. So I got to make sure that when I subtract, I put 7/10 first. 7/10 minus 2/5. Have to write them up and down. Turn them both into tenths. I already did that. So 7/10 minus, oh, that's easy. It's 3/10. 3/10. Okay. Now I have to multiply. Ooh, we just learned this one. So, oh, I don't even have like a mixed number or anything to worry about. I could just multiply across and get 14/50ths, but those are big numbers. But when I get 14/50ths, I can just cut them in half, It'd turn into 7/25ths. Or I could reduce first. So like the 2 and the 10, I could reduce that first. I could turn that into a 1, that into a 5, because I just cut them in half. I pretend like 2/10 is a fraction, and 2/10 gets simplified to 1/5. That makes it a little easier, and I get 7/25ths that way. But either way, it doesn't matter. It's 7/25ths. The even numbers, if you have extra time, you could start them after this video. If you do not have extra time, then on the even numbers, we'll do those together during our Zoom. So this is an even number. We'll do that together later. But you can try it if you have time. That'd be a great practice. So it says, Puzzle Penguin, this one falls on the odd side. That means I get to do it for you. Dear math students, remember you're writing this stuff in your book too. Dear math students, one of my friends said that he'd give me half of his sandwich and half of his sandwich to my sister too. That's good. So my friend said that he would give half of his sandwich to me and then half of his sandwich to my sister. My sister said, well, then you won't have any sandwich left for yourself. Doesn't make sense to me, Puzzled Penguin said. I know that 1/2 plus 1/2 is 2/4. So there's still a lot left over. What'd I do wrong? Do I need to get Drake out here? I won't do that to you. You can only add denominators, Puzzled Penguin. 1/2 plus 1/2 is 2/2. Your sister's right. Your sister got all the brains in the penguin family, right? So therefore, that's what you did wrong. You added the denominators. 1/2 plus 1/2 is a whole, or 2/2. All right, that's even. We'll do that later, or you can practice that after this video. Mr. Schwensen, he's making 2/5 quarts of grape jelly. He will give half of this to his neighbor. How much will his neighbor get? Well, his neighbor will get half of 2/5. Half of 2/5. So here's old Schwanson making some jam, and he makes 2/5. So 1, 2 out of 3, 4, 5. He makes this much. What a nice guy. Should be purple because jam's purple, right? He's going to give half of that. He's going to give half of that to his neighbor. So his neighbor's getting half of means multiply, 2/5. See how they're both 2s? I could totally reduce those. Turn them both into 1s instead. So now if I rewrite it to be a little neater, answer is 1/5. So that answer is 1/5. So how much will his neighbor get? 1/5. We could work on Mr. Schwentz. Okay, now let's go to 7. Yesterday, Mr. Schwentzen made 7/10 quarts of blueberry jam. His family ate 1/10 of it. How much was left? Ooh, tricky, tricky. If we do 1/10 of 7/10, we're only going to get how much was eaten. We will not get how much is left. So if he ate 1/10 of it, 9/10 of it is left. So we want to figure out what 9/10 of 7/10 is. That confusing? A little bit. Or you could just say 1/10 of means multiply, 7/10 equals, and I cannot reduce anywhere here, so I get 7/100ths, but that's only how much we ate. So if I had 7/10 and we ate 7/100ths, we want to figure out what's left. So I could turn this into 100ths by multiplying by 10, multiplying by 10. This is how much I had. This is how much I ate. There's 63/100ths left. And I'm pretty sure that's simplified. I'm pretty sure. And I'm not going to jump too much further into figuring out whether or not it is, but I'm pretty sure 63/100ths is simplified. So number 7 is 63/100ths. 8 we'll do later. And then check for understanding. Draw and complete a fraction box for 2/5 and 3/8. Circle the rows that require you to use a common denominator. Yeah, we're not worried about that. We'll do, if I have time in the Zoom, I'll do check for understanding there. All right, so that is our lesson video today. If you have extra time, get rocking on those evens, and I'll see you in the live Zoom.